The Greek alphabet has 24 uppercase letters and 24 lowercase letters. In each cell of a 24 by 24 grid, we write one uppercase Greek letters and one lowercase Greek letter, which each of the 24 square possible pairs appearing exactly once. Suppose that for each of the 48 symbols, the 24 cells containing the symbol form a connected region. Prove that the 24 cells containing the symbol omega either all lie in the same row or lie in the same column. Here, two cells are called connected if they share an edge. This is a cute combinatoric problem. Let's prove it. For simplicity, a 5 by 5 grid is used, and the uppercase and the lowercase Greek letters are replaced with A, B, C, D, E, and 1, 2, 3, 4, 5. We are going to answer two questions, then the proof will be done. The first question, the cells with the same letter or the same number are connected through shared edges. Then the question is, how many such edges are needed? Let's look at an example of connected region for letter A. There is a shared edge between A1 and A3, one between A3 and A2, between A2 and A4, and the last one, A4 and A5. Total 4 edges. But if the region contains a 2 by 2 block like this one, A2, A4, A5, and A1, then there will be more than 4 shared edges. The 2 by 2 block itself will contain 4 edges. So the answer to the first question, there are 5 letters and 5 numbers. Each of them needs at least 4 edges for connection. We would need at least 40 edges for such purpose. The second question, how many edges are available for sharing? Only interior edges can be shared. There are 20 vertical and 20 horizontal edges, so the answer is 40. Now look, we have only 40 edges for connecting the cells with the same letters or the same numbers, but we need at least 40 for such purpose. Then there are no extra resources for those 2 by 2 blocks. Moreover, all 40 interior edges have to be used to connect either the same letter or the same number, because we have only 40 such edges and we need all of them. For example, can B2 be a neighbor of A1? The answer is no. B and A are different, 2 and 1 are different. The edge in between is not shared by two cells with either a common letter or a common number. And we don't have such luxury of wasting even just one edge. This is the crucial part of the proof. All neighboring cells must be connected with either the same letter or the same number. By the way, all these calculations and conclusions work for 24 by 24 grid as set in the original problem. The last piece of the puzzle. Each connected region must lie on the same row or the same column. We already know there are no 2 by 2 blocks, but how about turning, like this one? A4 is a turning point for the region connecting A. Look at the 2 by 2 block containing A2, A4, A5, and an empty cell. What letter can we place in the empty cell? Not an A, otherwise we would have a 2 by 2 block of A. Let's put, say, B there. Then what is the number should be? The cell is a neighbor of A2 above it. They must share something in common, either the letter or the number. A and B are different, so the numbers must be the same. It is 2. But B2 and A5 are also neighbors, and they can have a common letter or a common number. Thank you for watching.